Hello everyone, myself Dr. Subhendu Sarkar. I am an assistant professor of Department of Chemistry, Brennova University. So today I am going to talk about thermodynamics. So let's begin. So what is thermodynamics? So the word thermodynamics was first used by William Thomson, who is popularly known as Lord Kelvin in 1949. So this is a subject which deals with heat flow or heat in transit, or we can summarily say that the branch of science which deals with energy flow or energy in transit. So now let's discuss the scope and applicability of thermodynamics. So the laws of thermodynamics are the generalization of experimental observations and experience gathered throughout years. So these laws of thermodynamics are universal and can be applied from biological system to even uh, bigger galaxies, and there is no known violation of these thermodynamic laws, and they are certainly correct. So now let us discuss the difference between classical and statistical thermodynamics. So classical thermodynamics, it doesn't involve any kind of assumption or postulate, and it is applicable to macroscopic or bulk system. On the other hand, statistical thermodynamics, it mainly concentrated on the dynamical nature of the microscopic particles or molecules, and then does some kind of assumptions to get the properties of the bulk system. So uh, now let's discuss some fundamental terminologies involved in thermodynamics. The first thing is the system and surrounding. So what is a system? So this is a part of the universe in which we are interested in. Say for example, I have a cup of tea. So for me, that cup of tea is a system, and the rest part of the universe, apart from the particular system, is considered as surroundings. And system and surrounding, they combinedly form the universe. Now, what is boundary or wall? So this is a physically or mentally constructed wall which separates the system from the surroundings. So this boundary can be categorized in different types depending on uh, mass flow, heat flow, or work done flow. Say for example, on the basis of mass flow, boundaries are of three types: permeable, semi-permeable, and impermeable. And on the basis of heat flow, boundaries are of two types: adiabatic wall or boundary, and diathermal boundary. And also on the basis of work done flow, boundaries can be categorized as rigid or non-movable, and non-rigid or movable. So what is the diathermal wall? So it allows the flow of energy as the form of heat between the system and surrounding. On the other hand, adiabatic wall or adiabatic boundary doesn't allow the flow of energy as the form of heat between the system and the surrounding. And for rigid boundary, it doesn't permit the flow of energy as a form of work done, uh, but the non-rigid or movable boundary, this permits the flow of energy as the form of work done. Say for example, uh, certain amount of gas is enclosed in a cylinder, and it is enclosed with a piston. If the piston is fixed in a particular position, then that will be called as a rigid boundary. And if the piston is movable, then that will be regarded as non-rigid boundary. So now let us describe the types of system. So I have pictorially represented here are the types of systems. These are mainly three categories: open system, closed system, and also isolated system. So what is a open system? So the mass as well as energy as the form of heat or work done occurs between the system and surroundings. Say for example, I have a boiling water in a beaker. So uh, the water vapor is escaping to the environment. So mass is transferring, and also the heat from the boiling water is also releasing to the environment. So this will be considered as open system. Now what is closed system? Only energy transfer as the form of heat of work done occurs between the system and surrounding. Say for example, a pressure cooker, a rubber balloon which is filled with air and tightly closed. And what is isolated system? Say for example, neither mass nor energy as the form of heat or work done occurs between system and surrounding. So our universe is an example of ideal isolated system because everything is happening inside this universe. So neither mass or nor energy can escape from the universe. So universe can be considered as an ideal isolated system. So now let's move on to another terminology, which is the property of a system or properties of a system. So what is the properties of a system? So these are some physical quantities or attributes which define a particular state of a system is called the properties of the system. So properties of the systems are categorized in broadly two types. First one is the extensive properties, and the other one is the intensive properties. So what are extensive and intensive properties? So an extensive properties is characteristics of the substance that depends on the quantity or depends on the amount of the substance, as for example mass, volume, etc. And intensive properties on the other hand, it doesn't directly depend on the quantity or amount of the substance. Say for example pressure, temperature, etc. So I have tried to pictorially represented here the how we can categorize an property as an extensive or intensive properties. Say for example, we have a system A, and we have a property for the system A called X. Now we have divided the system A into different parts, B and C. If xb plus xc equal to xa, that means the properties of the subsystems are are additively giving the properties of the uh, A system, the primary system, then X will be called an extensive property. But if it doesn't, that means if XB plus XC not equal to XA, then X will be called an intensive property. Now, so what is a state of a system? So a particular state of a system is characterized by the definite values of the properties of a system. Say for example, I have an gaseous system having pressure P1, volume V1, temperature T1 and number of moles N1, and I have another system where the pressure of the gas is P2, volume is V2, temperature T2 and number of moles is N2. So these two are the different state of a particular system. Now the equation which connects these two different states of a system is called an equation of state. Say for example, these two states of the system can be connected by this equation P1 V1 by N1 T1 equal to P2 V2 by N2 T equal to R. So this is called an equation of state. Now let's move on to another topic. So state and path functions. So as the name suggests, state function are the properties whose values depends only on the states of the system, that is the initial and final state, are called the state variables or state function. So the examples of state functions are pressure, volume, temperature, etc. Say for example, I have a gaseous system with initial pressure P1 and final pressure P2. Then the change of pressure delta P will be P2 minus P1. That means we can get the values, change of values of state function by simply subtracting the value from the final state to initial state. Whereas the properties which depends on the path through which the system is being transformed from one state to another state is called an path functions. So the examples are heat and work done. So these the value change of values of these two properties are explicitly dependent on the path through which the system is being transferred from one state to another state. Now, what is a process? So this is simply the description of the pathways through which a system is transformed from one state to another state. So processes can be broadly categorized in three types. The first one is reversible process, the second one is irreversible, and the third one is cyclic process. So what is a reversible process? So this takes infinite number of steps to complete, and consequently infinite time is required, and it will be a very slow process, and particularly at the each step of this process the system is in equilibrium with the surrounding, whereas irreversible process occurs in finite numbers of steps, so finite time is required, and this is a very fast process. And for irreversible process the system is in equilibrium only at the final state of the process. Now what is a cyclic process? So as the name suggests, the system is revert back to its initial state after covering some intermediate steps. So uh, there are also different kind of processes. So we will be discussing that one. So isothermal process. So as the name suggests, this in this process, temperature remains constant throughout. Adiabatic process. So in this process, heat is neither absorbed nor released. Isobaric process. So pressure of the system will remain constant throughout this process. And the last one is isochoric process. So here volume of the system will remain constant throughout the process. Now let us describe two important thermodynamic uh, properties. The first one is heat. So thermodynamics, since thermodynamics basically deals with heat flow or heat in transit, so we need to get a glimpse of what is heat. So this is a form of energy that transfers across the boundary due to temperature gradient or a difference in temperature between the two part of the system. And already I have spoken about it is a path dependent function. That means heat change of the system is explicitly dependent on the path through which the system is being transferred from one state to another state, and heat is involved due to the random or chaotic motions of the molecules. So what is work done then? So this is also a form of energy that transfers across the boundary or wall as the result of displacement of the boundary. That means work done can be transferred if only the boundary is movable or non-rigid. So like heat, work done is also an path function, and work done is involved due to the organized motion of the molecules. So that is the basic difference between heat and work done. So heat is involved due to chaotic motion, or but work done is involved due to organized motions of the molecules. Now let us describe heat capacity. So what is heat capacity? So heat capacity is the amount of heat required to raise the temperature of, of a substance by 1 degree. So this is called heat capacity. Now specific heat capacity is the amount of heat required to raise the temperature of a particular amount of, or like 1 gram or 1 kilogram of substance by 1 degree, and molar heat capacity is defined as the heat required to raise the temperature of 1 mole of substance by 1 degree. So for ideal gas, heat capacities are of two types, formally called as Cp and Cv. So Cv is the heat capacity at constant volume. For monoatomic gas, it is 3 by 2 R, and Cp is called the heat capacity at constant pressure. So for monoatomic gas, this is 5 by 2 R, and for constant volume process, we can easily write that the heat change Q equal to NCV per delta T, which is delta U, where R is the universal gas constant. So thank you everyone for listening me. Thank you.